In this video, I want to take a look at the second example we have of drawing slope fields. So this is going to be a slightly more complicated example than the last version, but really not that much more complicated at all. Let's take a look at it. All right, so here we go. We've got this time dy dx is equal to x minus y. And so we want to draw a slope field for every point in this grid. Okay, as I suggested, I think I would love it if you pause the video if you haven't already and take a stab at this. Maybe do it in pencil just in case you haven't gotten it right, but we'll take a look in a minute. All right, in the last video you saw that I kind of went through point by point, and that's fine, but let me show you kind of a way that I like to take a little bit of a shortcut through this. And the first is to kind of identify points that are easy to calculate and calculate those, and then figure out points that have the same slope and kind of handle them at the same time. So kind of in the sense that we did this entire column at the same time. I like doing that. So let's think about points where the slope is going to be 0. Those are nice because those are just horizontal lines. So when x and y are both equal to 0, the slope is going to be 0. So that gives us that going on right at the origin. What are some other points that are going to have this slope of 0? Well, it's going to be any time this is equal to 0. So if x and y are both 1, we're going to have that. If they're both equal to 2, because 2 minus 2 is 0. And you can see we kind of just pick up that whole line, it's a diagonal line, all at the same time just by thinking about all of the points where they're both going to be 0. Let's think of examples where it's going to be 1 as our solution. So if x is 1 and y is 0, that's going to give us a slope of 1. So x equals 1 and y equals 0 is this point right here. And I want this to have a slope of 1, which is just a 45-degree angle. And the same diagonal rule thing applies here. So this would be 2 minus 1, which is equal to 1. So that's another one of these lines. And off we go to the races. All right. How about negative 1? So if x is equal to 0 and y is equal to 1, then we've got negative 1. So that's a 45-degree angle just going in the opposite direction. And once again, we can just kind of line these all up diagonally. And now we can kind of spot the pattern. All right, so this is going to be the same, except it's going to be a slope of -2. So I'm just going to kind of eyeball it this time. I'm just kind of lining it up with this 2 points down and 1 point over. So my goal is not to be completely rash, but just a little bit faster than we were in the last video. And then these points are going to have a slope of +2 because this is 2 minus 0. So that's going to look, yeah, kind of like that. Up 2 over 1. Up 2 over 1. All right, and then over here, we're going to have +3. It's going to be even a little bit more. +4 is going to be kind of wacky steep. And now we can do the same thing over here. So this was -1. So this is going to be a slope of -2. This is going to be a slope of -3. And over here is going to be a slope of -4. So you can kind of see how this has a very different looking slope field. If we connected these dots together, we would get a very different shape than what we got in the first example. All right. So that just kind of gives an idea of how to make slope fields maybe a little bit faster. In the next video, we're going to go on to the second thing that we like to do with slope fields, which is once we have them, we're going to actually connect the lines together and find the solution to an individual equation based on the slope field.